Hello there. In this lesson, we're going to look at reflection. So reflection is what happens when light bounces off of a substance. And of course, there's different types of substances. The reason that we can see these trees on the shoreline in this picture is because the sun's light is bouncing off of them and into the camera or the eye of the person watching. The other type of reflection is when you have a really smooth substance like the surface of the water here. And so some of this light is bouncing off of the trees and then bouncing off of the lake and then into the camera. So that's why we see two images of the trees. One came straight from the tree, the other bounced off the lake. And so it's that type of reflection that we're going to look at today. So in order to understand reflection, we have to recall the options for what happens when light encounters an object. So first of all, recall that light travels in straight lines, which you can kind of see in this image that I took when we were at Cave and Basin National Park, which is Canada's first national park. It's pretty awesome. So what happens, you can see in this picture, is that these nice straight light beams are coming in and they're interacting with the objects in the room. So the dark objects that are opaque means that they're going to be absorbing the light. Bright objects or bright places, that means they're going to be reflecting the light. It's bouncing off of it. And then you got options in between. You've got transparent objects like the water in the basin down here where the light can penetrate right through. And then of course there are some substances that are kind of in between where some of the light gets through and some of it gets dispersed or reflected. So there are different ways in which light can bounce off of surfaces depending on how smooth the surface is. So in this lesson, we're going to focus on really smooth and shiny surfaces. You can think like a flat piece of aluminum foil. All the light rays that come in are going to stay parallel to each other when they bounce off. And it's those type of surfaces that we're going to focus on. Those are the ones where you can see an image in it. Now, if you take that aluminum foil and crumple it up, well, you don't get very good images because the light bounces off in a whole bunch of different directions. So we're going to focus on nice smooth surfaces that give us this specular type of reflection rather than a diffuse reflection. So when you have a nice smooth shiny surface, what you end up producing is an image of the object that has the light bouncing off of that surface. And so you can see that in this picture that I included here, which is Mr. Heron that comes to the pond near our house here. And there's an image of the heron in the pond below. And that's because of the light bouncing cleanly off of that shiny surface of the water into the eye. And then you produce the image that'll be inverted below. So there are some laws that govern the behavior of light when it bounces off a flat, shiny surface. And the first one is that when you have light that is striking the surface, that's called the incident ray, and the light that bounces off of the surface, that's called the reflected ray, those two are going to be in the same flat plane along with a 90-degree line called the normal to the surface of that shiny surface. The second law is when you measure the angle between the normal and the incident ray, that's called the angle of incidence. So if you measure from here, the normal, to the incident ray, so going this way, you'll see it's 10, 20, 30, 40, 50 degrees. So the angle of incidence, 50 degrees. And then if we do the same thing on the other side and measure the angle of the reflected ray, so that's from here over to here, it's also 10, 20, 30, 40, 50 degrees. And so the second law is that the angle of incidence, which is this, and the angle of reflection are always going to be equal in a plane mirror. The type of image that's produced by a plane mirror is called virtual. And that means that there's no actual light coming from the place where the image is perceived to be. Of course, we know this, but our brains are kind of tricked by the mirror because our brains perceive objects based on the principle that light travels in straight lines and not that light is bouncing off. So our brains think that there's an object in there, or give us that perception that there's an object in there, even though there's no actual light coming from that spot. So that's why it's called a virtual image, because there's no actual light coming from the place where our brains are perceiving that image to be. So to represent the virtual image of an object in a plane mirror, we usually use the ray lines to show where that object will be. So if we put our angle of incident line and reflected line, we can see that the eye is going to perceive that the light coming from this object here is going to be coming from this space here. And then the distance that the light travels, our eyes are going to perceive that the object is way back here behind the surface of the mirror or the lake or whatever it is that's reflecting the light. So we usually represent any of these virtual light rays with a dashed line and actual light rays with a solid line. So the next challenge is to find the location of an image given an object. And it's pretty easy to do with a flat mirror, plane mirror. All you need to do is to draw on some lines that are 90 degrees to the surface of the mirror. So if we draw this on here and we measure it and say it's like 5 centimeters, then we can draw another 5 centimeters to the other side, and that'll be where the image is, the same point in the image. And if we do the next one, say this might be 4 centimeters, and then we put a virtual light ray there for 4 centimeters, and then we do the last one, and maybe that's a little bit more, maybe that's 5.5 centimeters, and we do the same thing over 5.5, and once you have enough points on your image, then you can just assume where it's going to be from there. Another interesting feature of an image compared to the object that's being reflected is that the image will have that flipped appearance. We all know that our reflected image is not the same as the image you see in a picture of ourselves, and that is because left and right are flipped when it comes to the image compared to the object. So if we look at the Rubik's Cube, we can see this green squares on the right-hand side of the object, and over here in the image, it's on the left-hand side. So that means that our image has been rotated laterally or flipped laterally compared to the object. However, the thing that stays the same is that we are still upright. The image is upright compared to the object, so that stays the same, just flipped left and right. So there are 4 characteristics that we're going to use to describe an image compared to an object, and you can remember them by using this little acronym S.A.L.T. So the first one is the size of the image. Is the image bigger or smaller than the object? And with a flat mirror, we know that the image is going to be the same size. The second one is called attitude. Attitude is referring to whether or not the image is upright compared to the object or if it's been flipped. And you can see here that the image is upright compared to the object. They're both going the same way. The third one is location. Is the image further or closer to the reflective surface than the object? And you already know that for a flat surface that the location will be the same distance to the reflective surface. And finally is the type of image. If it appears that the light is coming from behind the reflective surface, that's called a virtual image, and that's what you have with a flat mirror. Some mirrors will produce an image on the same side as the object, and you would call that a real image. So we'll see some of that in the lessons going forward. Alrighty, I hope that helped you, and we'll talk again soon.